All right, I'm going over the Unit 2 review. Number 1 says to rewrite with an exponent. So x is the base, and then remember for an exponent we're going to have a fraction. The root is on the bottom. Just like roots grow underground, it's in the denominator. So 7 is the root, and 3 is the exponent. The next one we're going to rewrite it as radical. So this time we're going to write a radical. This is the radical symbol. The base is 2. And remember, roots grow on the bottom and roots go in front here, which is the 3, and then 4 is either you could write it outside as the exponent this way, or it's still okay to write it in the inside of the radical. So either one of these two answers are okay as an answer. So this would be correct. This would also be correct. All right, let's actually evaluate. So when we evaluate the expression, let's rewrite it in a radical form and then simplify. So this is a 2 for the root, so this is a square root of 9. You don't have to write the 2 here, and you don't have to write the 1 there. It's automatically known to be a square root without a number, and it's automatically raised to the first power without a number out there. So really we're looking at the square root of 9. And you might know the square root of 9 already without having to do a breakdown, but if you do, break it down. 9 is 3 times 3. So the square root of 9, we're looking for 2 of a kind, right? That's the root. So we have 2 3's. Square root of 9 is just 3. All right, the next one, let's go ahead and rewrite this in a radical form. So we're going to write it with the 16 inside the radical. 2 again is the root, 3 is the exponent. Yes, you could put the 2 there if you want to. You don't have to. Without a number there, it's a square root, but we are looking for 2 of the same number. You can break down the 16 and say 4 times 4. Since I have 2 of the same number, you can go ahead and use that as 4, but let's say you didn't realize that, or you did 2 and 8, and you end up with 4 2's at the end. So you're looking for 2 of kind, so I have 2 2's here, that's a set of 2, times, and have another set of 2, you always multiply them together, 2 times 2 is 4, but you're not done yet because we still have this cube, so it's going to be really 4 cubed, that little 3. And 4 times 4 times 4 is 64. Okay. All right, this next one right here, we're going to simplify this before we actually do the fraction. So we're going to do the 5th root of 32, remember the roots are on the bottom, over the third or cube root, sorry, of 64. Some of you already know the answers to this, which is completely fine. If not, I'll break it down. That's 8 times 4. 8 breaks down to 4 and 2, 4 breaks down to 2 and 2, and this 4 breaks down to 2 and 2. So I actually have 1, 2, 3, 4, 5 2's, exactly 5. So the numerator is just going to be 2. And now we'll do the bottom. 64 breaks down to 4 times 16, and 16 breaks down to 4 and 4. So you can see I have 3 of the same number, so you can say that's 4. But let's say you kept going. You went 2 and 2. 2 and 2, 2 and 2. We're looking for 3 of the numbers. 1, 2, 3 2's there, another set of 1, 2, 3 2's there. So that's really 1, 2, 3, that's a set of 2. 1, 2, 3, that's another set of 2. 2 times 2 gets you the 4, which would have been the same thing as taking it from here. But 2 over 4 actually reduces to 1/2. Over here, again, we have to simplify it before we actually add. So we're going to do the square root of 4, that's the 2 out here, plus this one's going to be the cube root of 8, and then we're going to square it. All right, the square root of 4, break it down, we have 2 and 2. I have exactly 2 sets. Remember, that's a 2 here, right, square root. So that's going to be just 2, plus over here, we have to break down the 8, which is 4 times 2. 4 is 2 times 2. I actually have 3 of the same number, and that's what we want. I have 3 2's, but you're not done with this because you still have the square right there. So it's 2 squared. You have to do exponents before you add. So we're going to have to do 2 squared first, which is 4, and then 2 plus 4 gets you the 6. Okay. All right, let's go down to the simplifying where you multiply now. All right, so here what we're going to do is we're going to multiply the numbers together first. 3 times 5 is 15. We have x squared, and remember this is x to the first. So we have a total of 2 times 1 more x makes a total of 3. For y, we have 2 here and 4 more there. Remember, you add the exponents. 2 plus 4 is 6. Okay. Over here, what we're going to do is we're going to simplify the top first. So let's add the exponents again. So 4 plus a negative 2 is 2. You have a to the 7th on the bottom. All right?
Thank you.
So you have 2 on top, 7 on bottom. So you actually have more a's on bottom. How many more? I have a total of 5 more a's on the bottom. And if you look at this right here, you're canceling out completely 2 2's, so you only have the number 1 on top. Now, if you didn't follow that, you can always take this right here and write it out. That's 2 a's over 7 a's. 1, 2, 3, 4, 5, 6, 7. And you're really canceling out one set of a's and then another set of a's. And that leaves you with 5 a's on the bottom, but there's nothing on top, so you have to think of it as a 1 on top. Okay, and that's how we got that. All right, let's go ahead and take a look at this one right here. So what we're going to do here is we're going to break down the 16 and see if we have 4 the same number. That's 4 times 4, and 4 breaks down to 2 and 2, 2 and 2. So I have 1, 2, 3, 4 2's. So I have exactly 4 2's, so that goes outside. There's no number left over because I used all 4 of these, and so nothing goes inside the radical as far as the number. Let's do the a to the 8th. How many times does 4 go into 8? 2 times. Okay. If you really wanted to write it out, you can write down your 8 a's. That's 1 set. So that makes 2, and you have a squared. All right, how many times does 4 go into 20? That goes in there a total of 5 times. So actually, this one has no leftovers whatsoever. All right, let's look at this one. This is going to be 3 times 9, 3 times 3, and I want 3 of a kind, so I actually have exactly 3 3s, so that 3 is on the outside. All right, let's see about leftovers. There's no leftover numbers, so nothing's going to go inside so far. Here we have x to the 5th. 3 goes into 5 one time, but there's 2 left over, so I'm going to leave a little space for my y's and z's. But I'm going to go ahead and make sure you put the little 3 for this cube root, and I did have 2 x's left. If you didn't get that, you can write it out. 1, 2, 3, 4, 5 x's. There's a set of 3 that goes outside, and then the 2 left over is the one that goes inside. All right, how many times does 3 go into 11? It goes in there 3 times, so y to the 3rd. That gets you 9. We still have 2 left over. 10, 11. 3 goes into 6 exactly 2 times, and there's no left over. All right, is the term a monomial? If not, explain why. All right, so let's see. Is this term a monomial? Yes, it is. It's one term with a whole number exponent. All right, how about this one? Oh, see that negative right there? No. It doesn't have a whole number exponent. Or you can say the exponent is negative. You can say the exponent is negative. 27, is that? Yes. Remember that a monomial could be a number, a variable, or a combination of both being multiplied. All right, degree of the expression. So remember, you have to add each term's degree, or each term's exponent for the degree. This is one term. This is one term. This one actually has 1, 2, 3, 4 terms. So we're going to have to figure out that one a little bit differently. All right, this one right here, this a has an exponent of 1, the b has an exponent of 1, so this degree is 2. 1 plus 1, you add. All right, that has 3, that has 1, add the exponents. 3 plus 1 is 4. Here, 3 plus 2 is 5. There's only a 2 for the exponent. This has a 1, and this has 1. So which one has the highest? 5. So the degree is 5. You pick the highest one out of all of the separate degrees. Okay. All right, now let's go ahead and do some simplifying here. So when you simplify, you can use the box method, you could use the distributing method. I'm going to go ahead and use the distributing method. I'm I'm going to multiply this 2x to each one. 2x times 2x is 4x squared. 2x times 5 gets you a positive 10x. A negative 5 times 2x is a negative 10x. And then a negative 5 times 5 is a negative 25. Now I'm going to add this together. These are like terms. But 10 minus 10 is actually 0, so that goes away. So 4x squared minus 25. Now keep in mind, this is asking us to not only simplify the expression, this is simplifying it, then we're going to identify if it results in this. Is that the same? Yes, it is. Okay. All right, let's take this next one. Distribute. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 25 times x is 25x. And then 25 times negative 1 is negative 25. All right, our like terms are here in the middle. So we're going to put that together. 4x squared plus 21x, the 25 minus the 4, and then minus 25. So this is the simplified answer. So you have to simplify. It says to simplify. Then we're going to see if it's the same. Is that the same? Definitely not. This one has that middle term of 21x. All right, let's do the next one. This one right here, we're going to have to FOIL this, and then we'll add this at the end. So let's go ahead and rewrite this here as 2x plus 5 times 2x plus 5. All right, let's FOIL. 2x times 2x, that's going to be a 4x squared. And so I already did that part. 2x times 5 is 10x. Then we have 5 times 2x, which is another 10x. Then we have 5 times 5, which is 25. Keep in mind, once we FOIL, the parentheses go away, and we can just tack on this at the end. There's still a negative 20x, and there's still the negative 50 after we multiply this out. All right, time to add like terms. There's a lot of like terms here. We have a 4x squared, that's the highest power. So I'm done with that. Now I have to add my x's. I actually have a lot of x's here. I have 10 plus 10, which makes 20, but 20 minus the 20x, that goes away completely. They cancel each other out. And the last part is 25 minus the 50, which is a negative 25. So this is it simplified. And then the question says, does this result in the same? And yes, it does. All right, the last one of this, let's go ahead and multiply this out. So that's the same thing as saying 2x minus 5 times 2x minus 5 when you square something. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And then negative 5 times negative 5 is a positive 25. Keep in mind we're not done because we actually have these two terms at the end. So we're going to add 20x and we're going to add the 50. All right, let's go ahead and add like terms. Start with the highest power. There's a 4x squared. There's no other x squareds. Now I'm going to add my x's. I have a negative 10x and a negative 10x. That makes negative 20x. And negative 20 plus 20 also cancels. Negative 20 plus 20 is 0. And then 25 plus 50 gets you 75. So that's it simplified. Does this match this result? Definitely not. Plus 75 is not the same. So that's a no. All right, let's go to the next section, which is add or subtract. So what we're going to do is we're going to go ahead and first just look at like terms. Start with the highest power. The one with the highest power is x squared. So we're going to put these together. Negative 4x squared and a positive 2x squared. That gets you a negative 2x squared. Next, I'm going to put my x's together, which is a 7x plus 3x. And that gets you 10x. Okay. All right, this next one right here has m's. Start with the highest power again. 8m squared and m squared makes a total of a 9m squared. Now we're going to look for m's, and I only have one here, which is the negative 10m. And then we do have numbers we can put together. Negative 15 plus 8 is negative 7. Okay, make sure it's in standard form. All right, whenever you subtract, you have to distribute the negative. So I'm going to rewrite the beginning and not do anything with that. Now I'm going to distribute the negative. Negative times 7x squared is negative 7x squared. And then negative times a negative 8 make a positive 8x. All right, let's add And I do have two x squareds here. Negative 3 minus 7 is negative 4, x squared. Keep that exponent. And then the two that I can put together is the 4x with the 8x, and that gets me a total of 12x. All right, another distributing problem down here. So we're going to distribute the negative here. So rewrite the beginning. And then negative times a negative is positive 2x squared. Negative times a positive is negative 3x. Negative times a negative is positive 7. All right, adding like terms, get your squares together. So we have 3x squared, 1 plus 2. Then put the x's together. I have a 5x minus 3x, which makes 2x. And then negative 6 plus 7 gets you 1. And so that would be it in standard form. Okay, I'm going to do the backside as a separate recording.